All right, let's jump right in. Have you ever wondered how a piece of technology that's supposed to be brilliant can sometimes lead to an absolute disaster? Today, we're going to uncover the invisible forces, this hidden relationship between people and their tools that really determines whether the things we create end up helping us or hurting us. And I mean, the stakes here are as high as they get. We're really asking, why can one system save lives and change an industry for the better, while another, which seems just as smart on paper, ends up costing them? The answer, you'll see, isn't just in the code or the circuits. It's something much, much deeper.
So, to really get to the bottom of this, we're going to look at a tale of two very different systems. One comes from the high-pressure world of aerospace engineering, and the other from a, surprisingly innovative corner of community healthcare.
And the contrast couldn't be more dramatic, right? On one hand, you have the Boeing 737 MAX. A software fix which was supposed to increase safety tragically leads to the loss of 346 lives. Then on the other, you have this Dutch nursing organization, Buurtzorg, using a super simple IT system to deliver the best patient care in the country for less money. How is that possible? Well, believe it or not, the same hidden principle is the key to both of these stories.
Okay, so let's start with the tragedy, because it's a powerful way to understand the danger here. The story of the Boeing 737 MAX is, unfortunately, a perfect example of what happens when that crucial bond between tech and its human users just completely shatters.
So the problem began with a change to the plane's physical design. To fix it, engineers came up with a software solution called MCAS. Now, if you're looking at it just from a technical perspective, it was a totally logical fix. The software was designed to work behind the scenes, making automatic adjustments to keep the plane flying smoothly.
But here it is. This is the critical, fatal piece of the puzzle. A decision was made, mainly for financial reasons, to save money on pilot training. And to do that, they decided not to even tell the pilots that this new, very powerful software was on the plane. The human operators, the people actually flying the plane, were left completely in the dark about a system that could take control away from them. And this is a textbook case of what we call socio-technical dissonance. It's a fancy term for when the tech and the people are just not on the same page, at all. The MKS software was just following its rigid code, its logic. But the pilots, the human part of the system, had no way to adapt because they were missing the most crucial piece of information. The tech was designed in a total vacuum, completely separate from the people who had to use it under incredible pressure. So that's what failure looks like. It's a scary picture. But what about success? Let's pivot to the Buurtzorg model in the Netherlands. You're going to see how they achieved a totally different outcome because they started with a totally different way of thinking. Now notice what Buurtzorg did here. They didn't start by asking, what's the cool new tech we can buy? No. They started by designing their social system first. They asked, how do we empower our nurses to do the best possible job? And the answer was, small, self-managing teams. No middle managers. Giving them the freedom, the autonomy to make their own decisions. They put their trust in their people, first and foremost. It was only after they figured out the human part of the system that they even brought in the technology. And when they did, that tech had one job and one job only, to serve those teams. It handled the boring stuff, right? The billing, the scheduling, all the administrative headaches. This freed up the nurses to focus on the thing that actually matters, caring for their patients. The tech supported the people. It never tried to control them. And this, right here, is the solution. It's called joint optimization. It's the polar opposite of that dissonance we saw with Boeing. It's that moment when you stop designing tools and people as two separate things, and you start designing the relationship between them, making absolutely sure that each one supports the other. Okay, so this all sounds great in theory, but as students, as the people who are actually going to be building the future, how do you do this? How do you avoid the disasters and actually achieve this kind of optimization in your own projects? Well, let's open up the toolkit. So a real socio-technical design process, it looks a little different from what you might be used to. Look at step 2. You don't just set technical goals, you have to explicitly define social goals too. Things like, we want to increase team autonomy. And check out step 3. You don't just prototype an interface, you prototype the entire workflow with people. You're testing that human-tech partnership from the very first day. So how on earth do you map out all that messy human stuff? You know, the culture, the office politics, the things no one ever writes down? Well, one of the coolest, most powerful techniques is called rich pictures. And yes, it is literally what it sounds like. You get everyone in a room to draw cartoons of the situation. It might feel a little silly, but it's an unbelievably effective way to surface all the fears, frustrations, and power dynamics that a normal spreadsheet or report would never, ever capture.
So, why are we digging up a theory that's been around since the 1950s? Because it has never been more important than it is at this very moment. And the reason for that can be summed up in 2 letters: AI.
This might be the single most important socio-technical question you face in your entire career. When you bring a generative AI into a workflow, you're not just installing another piece of software, you are, for all intents and purposes, hiring a new, very strange, non-human team member. And you absolutely have to design for that new relationship. The risk here is a newer, maybe even more dangerous kind of dissonance. Think about what we could call socio-technical hallucinations. This is when an AI makes a mistake, a hallucination, but it's so well written, so plausible, that it actually fools the human expert into believing it's true. The technical system fails, and it pulls the social system right down with it. The potential for disaster is just as real as it was with the 737 MAX, only now it's in our hospitals, our courtrooms, everywhere.
So here's the bottom line, the big takeaway for all of you. For the rest of your careers, the projects that truly succeed won't be the ones with the flashiest tech or the fastest processors. They're going to be the ones that build the best, most supportive, most human-centered relationship between people and their technology. Your challenge isn't just to build amazing tech, it's to build a healthy society with that tech. So what kind of relationship are you going to design?